When talking about light dispersion, one interesting thing to discuss is rainbows. Rainbows, that's one of the natural phenomena that allows us to see the spectrum of colors. So why do they do so? Before explaining it, let's look at some pictures. Okay, rainbows, we can get them from, if we are using a sprinkler system, for example, we have the sprinkler on and we have enough water in the atmosphere. By looking towards the water at the right circumstances, with the sun in the right direction, we should be able to see a rainbow. Now here, this is a rainbow we can observe from a waterfall. This is Victoria Falls. Now, you noticed in here, the rainbow looks like an arc. Actually, if you look at a rainbow from an airplane or from a high enough place, in this particular case it does not look like an airplane, but you should be able to see a full circle rainbow. This is if you go around to some large falls like the Niagara Falls, you should be able to see something like this. Now there are other features like what we have here looking like a rainbow fire. I'm not going to specifically talk about this since I honestly don't know much about it, but we have features like this. Now, one thing to notice about rainbows, we have two things. You see here, this is the primary rainbow. See, there is blue light at the bottom, and then green, yellow, and then red. And then we have a secondary rainbow on top. And the secondary rainbow is less bright, but it is inverted. It's the reverse of the top one. So we have the red at the bottom and the blue at the top. This is another view of a rainbow. Okay, again, like this one where we have blue at the bottom, we have blue at the bottom, then red at the top, and then the inverted rainbow here, you see red here and then blue at the other end. In this particular picture, we have a reflection of the rainbow on water, and it seems an image of this reflection on the sky here. I really have no idea otherwise what it is. So we have these multi-reflections of rainbows and a reflection of the secondary rainbow here. Neat picture. Now let's try to explain it based on the simulation. Okay, here's the simulation. Now, in this particular case, I have red light hitting a water droplet. Remember, for a rainbow, it happens after rain or near a waterfall or when the sprinkler is running. So whenever you have water in the air, so this is a water droplet, and we are shining light on it. As the light hits it, part of it, consider this as the perpendicular, it's along the radius, so part of it is reflected, part of it is transmitted. The transmitted part, once it meets this new interface, part of it is going to be reflected, part of it is going to be transmitted. And then we go on, and then part of it is going to be transmitted, part of it is going to be reflected. And when we get to here, we have essentially the same story. If we have blue light, we have the same thing, except because the index of refraction is different for different wavelengths, blue light is going to bend more. Now, what if we look at it with white light? Here is we look at it with white light. Now, in here, we are seeing blue light, green and red, and the reverse here. Red, green and blue. And you notice how the strength is different. This is a little dimmer than this one. Okay, now let's look at it in okay. You notice here we can observe this rainbow from here, can observe this other rainbow from here. So it depends on the angle you look at things. Oops. So essentially the bottom line is we have a rainbow just because of the way the light is going to be refracted through the water droplet. And we have two different rainbows. That's because one of the beams is going to be the transmitted beam and the other one is not going to be the fully transmitted beam. It's going to be a little bit of what's transmitted here.